Welcome to the Clear Linux OS Architecture Overview. This video will cover the basic technical architecture concepts of the Clear Linux OS. You don't need to have any prior experience with the Clear Linux project to follow along, but you will find it helpful to have a working knowledge of Linux systems and a basic understanding of how software is configured and built in a Linux environment. Let's get started. I'll start with a quick overview of Clear Linux philosophy and goals, followed by a deeper look at some interesting features in the OS, such as our stateless design and the various performance optimizations we make. I'll explain how bundles enable functionality on the system by delivering entire software stacks, and finally how that content is built, delivered to clients, and how users can create their own derivatives of Clear Linux and add custom content to their OS. First, I'll give you a brief overview of several features and philosophies that make Clear Linux unique. Clear Linux is an OS that has been highly optimized to utilize IA features in the software it provides. Performance enhancements in our software packages are being released every week. As a rolling release distribution, Clear Linux aims to provide an average of 9 releases per week. These releases provide various updates to system software to improve performance or patch the latest security vulnerabilities. We make releases so often because we believe an out-of-date system is an insecure system. We have tooling in place to detect when a CVE has been identified and have a team policy of patching those vulnerabilities within 24 hours of a fix becoming available. Our rolling release cadence helps us achieve that goal. Performance optimizations for IA are an important part of what makes Clear Linux unique. Next, I'll talk about how these performance optimizations are achieved in Clear Linux. The Clear Linux team has worked to optimize the entire dependency stack of critical software that we ship. We do this in several ways. Across all software, we compile with a Westmere baseline and tune to a Haswell architecture. Optimized libraries can be selected at runtime by the dynamic linker based on the available CPU features on the client system. We have also worked to directly patch critical software to improve performance, and much of this work has been accepted upstream. All the optimizations that we provide are open source and can be found on github.com/clearlinux-pkgs. An example of an optimized package can be found at this link. While other OS distributions provide individual software packages with dependencies resolved at install or runtime, Clear Linux ships software in bundles. Bundles are collections of integrated packages designed to provide a specific functionality to the end user. Bundles are shipped with all dependencies resolved at build time, so installing a bundle on your system means the use case will just work. Bundles can be compared to package groups in other Linux distributions, but instead of a horizontally integrated collection of similar packages, bundles are a vertical integration of an entire software stack. Bundles can range in size from large framework bundles to small bundles that provide a single binary to the end user. Another unique feature of the Clear Linux OS is its stateless design. Stateless design means a couple of things. We have patched the packages we provide to ship complete default configuration in user-shared defaults so that installed software will work out of the box. The default configuration files are also often tuned to the most secure options available. These shipped defaults can be overridden or modified by the user placing a system-wide configuration file under etc or a user configuration file in the home directory under .config. While other operating systems will ship incomplete configuration files under etc or even in the home directory, Clear Linux maintains a clear separation of configuration data. A benefit of this approach is that wiping etc and var performs a factory reset on the system by removing user modifications and restoring the OS default configs. I will now cover Clear Linux update principles, how updates are created via a process called mixing, how those updates are consumed on client systems, and how users can create derivative custom mixes and sideload custom content onto an installed Clear Linux instance. Clear Linux updates are different from most Linux distributions in that they require you to update all bundles at once. One OS version describes all software versions installed on that system. This enables our QA to run against an entire OS instead of trying to cover all combinations of installed package versions. It also means we can do dependency resolution at build time instead of trying to resolve dependencies at software install time or runtime. Clear Linux updates are designed to be proportional. If only one file in a bundle changed in an update, the client only needs to download that file to update the bundle. It is not required to download and install the entire bundle again. Because of our security posture, we enable auto update by default. This means that you will get updates on average twice per business day as we release the latest security patches. A user can disable this feature if they wish. The Mixer tool is used to build bundles into update artifacts that can be consumed by the software updater on the clients. Mixer uses bundle definition files and upstream package sources in the form of RPM packages to generate a bundle data object we refer to as bundle info files. The bundle info files contain all relevant bundle metadata, including package and file lists. All file content is also installed to a full build root. These bundle info files are then used by the update creator to generate the artifacts that are consumed by the software updater swapd. Among other operations, the update creator deduplicates the file list for each bundle with the bundles it includes to reduce manifest size and simplify client operations. The update creator uses the full build route to generate the actual file update content to be downloaded by the client. Mixer produces an artifact called a manifest. A manifest is a human-readable file that describes the content that a certain bundle provides and is used by the client to apply and validate installs and updates. The example here is a manifest for the Go Basic bundle, which provides the Go programming language. After a header section that describes metadata for the bundle at the current version of the OS, all the files that the bundle provides are listed. Each file record starts with a section of flags that tell the client how to handle the file. The example shows two regular files denoted by the F flag. Other file types are denoted by D for directories and L for links. The flags are followed by the SHA-256 hash of the content and various file metadata such as the owner and group. This allows swapd to verify that the files on the system are correct. Each file record lists the version at which the file was last updated and the name of the file. Each manifest file is itself listed in a manifest of manifests, or MOM. The MOM is just like any other manifest, except that instead of listing files that are installed in the OS, it lists each bundle manifest file that is published for that OS release, along with the hash of the manifest file itself. The MOM and bundle manifests describe our security model. The MOM is signed with OpenSSL using a secure signing service and lists the hashes for each bundle manifest. Each bundle manifest file can then be trusted if their hash matches the hash listed in the MOM. Each file that a bundle provides can then be verified via the hash listed in that bundle's manifest. So with only the manifest.mom signed, we can see verification cascades through the SHA-256 hashes to the file level. Mixer also produces packs that contain all the content needed to update a bundle from version X to version Y. They contain all the full files and binary delta files needed to update that bundle on the client system. Binary delta files contain only the patch required to update a file on the file system. The patch is generated by comparing the old and new versions of the file, so the client only has to download the changed portion and apply it to their file on the system. Zero packs contain only the complete set of full files needed to install that bundle fresh on the client system. Full files are always available for swapd to download if it is unable to use a pack for whatever reason, such as pack download or extraction failure. Updating is performed at the file level and is done in stages. First, the MOM is downloaded and verified. Then, delta packs are downloaded for each updated bundle. The packs are extracted and the delta files are applied and staged. Any full files are also downloaded and staged. Each file that will be applied to the file system is verified against the hashes in the manifests to validate correctness. All of this can be interrupted and resumed or restarted. The most crucial part of the update happens in the last few milliseconds when swapd is renaming all staged files to their final locations on disk. This is a critical step because interrupting it could potentially update a dependency for a package while not yet updating the package itself. Because of the staged approach to updating, this is a very quick operation. The Mixer tool was developed in a way that allows users to create custom mixes of Clear Linux by selectively consuming upstream content and adding whatever custom content they desire. Mixer can combine these sources and publish your custom content to allow you to become your own OSV based on Clear Linux. The same update artifacts are published and can be consumed by swapd in the same way. If a user does not want to do the work of hosting their own Clear Linux derivative, they can use a wrapper tool called Mixin, which creates a minimal local mix on the client system. The artifacts from this local mix are merged with the artifacts from upstream Clear Linux, allowing the client to continue receiving updates from upstream while keeping their side-loaded custom content intact. Clear Linux is a unique Linux distribution that continuously releases the latest available security updates. Configuration data is clearly partitioned into a stateless design. Software is optimized for the latest IA features and provided via use case-focused bundles. These bundles are updated securely and quickly with the software updater. Clear Linux is a modular open source OS that meets the needs of today's security-concerned world. To see the latest developments and track our project, visit us on GitHub. You can find more information about Clear Linux features, usage tutorials, and documentation on our website and contact us via the links on the screen.